Hello, this is Mr. Miller, and this is a special video. In this video, we're going to review the solutions to the review problems for the mini quiz tomorrow. Alright, let's take a look at the first problem. The first problem goes back to the definition of derivative. We can't forget how to do that. It says use the definition of derivative to find the derivative of f of x equals 7x squared. And we have to show all our work. Okay, no problem. So I like to start with stating what the derivative is. So f prime of x, the derivative of f of x, is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, that's the definition of the derivative, and if we evaluate that limit, we should come up with the derivative, which we know now should be 14x. Okay, so we know the answer we're supposed to be getting. Okay, so this is the limit as delta x goes to 0 of, well, we need to substitute x plus delta x into the function. So we have 7 times quantity x plus delta x squared minus f of x, that's minus 7x squared, divided by delta x. Okay, remember this is the limit of secant lines. This is an expression for the slope of a secant line, and we're letting the secant line approach the tangent line. Alright, so this is the limit as delta x goes to 0 of 7. When we square this out, we get x squared plus 2x delta x plus delta x squared minus 7x squared all over delta x. So we're used to doing a lot of algebra. No surprise to us anymore. And so if we distribute the 7, we get 7x squared plus 14x delta x plus 7 delta x squared minus 7x squared all over delta x. 7x squareds cancel, and we can factor out a delta x here. Every term has a delta x in it. So we get the limit as delta x goes to 0 of delta x times 14x plus 7 delta x, yeah, just like that, all over delta x. So I factored out a delta x here, that leaves a 14x. If I factor out one delta x out of this, that just leaves 7 times delta x. Delta x is cancel, and we're getting close. We got the limit as delta x goes to 0 of 14x plus 7 delta x. As delta x goes to 0, this goes to 0, and we're just left with 14x, which is what we're supposed to end up with. Okay, so that's the formula for the derivative. Wow. Alright, that's probably the hardest part right there. Okay, now we have a question that ties in some things from the last chapter, the last unit. We want to know, does the limit as x approaches 2, h of x exists? This is h of x here. It's kind of a w-shaped function. Well, x equals 2 is right here, and as x approaches 2, we see that the value of the limit does exist. It approaches 0. From the left side, it approaches 0. From the right side, it approaches 0. So does it exist? Yes. In fact, the limit as x approaches 2 of h of x equals 0. Alright, now, is h continuous? Well, in order to be continuous at 2, the limit has to exist. So that's true, the limit has to exist. The function has to exist. That's true, because the value of the function is 0, and the limit equals the function. That's the condition for continuity. So pretty much the function approaches what it's actually equal to, and that's true. It approaches 0 from both sides, and it actually equals 0 right there. Now, so yes, in other words, yes, we met the criteria for it to be continuous there. You don't have to pick up your pencil to draw the function. So remember, that's kind of a definition of continuity. If you can draw the function without picking up your pencil, it's continuous. All right, now, here's a question we have to talk more about in class. We haven't talked a lot about. Does the derivative of h exist at 2? And the answer is no. It doesn't have a derivative right here. When a function has a sharp corner like this, it doesn't have one unique tangent line. There are a lot of lines I could draw there that just touch the function in one place. So it's not really defined. Another way you can think about it is the slope coming from the left is negative, but the slope on the right is positive. It abruptly switches from a negative slope to a positive slope. So the slope actually at 2 doesn't exist. If we looked at the definition of the derivative, the limit from the left and the limit from the right wouldn't be the same. Okay, so limit exists, is continuous, but there's not a unique tangent line there. The derivative does not exist. Right, that we have to go over some more. It's not a big deal, but we'll talk about it some more. By the way, the derivative exists up here, and it's 0 because there's only one tangent line there. Same with a point like this right here. There's one tangent line there. But at -2, here's another point where we could draw a lot of lines that just touch at once. There's no unique tangent line right there. So no derivative at those corner points. All right, now I want to practice some rules here. So this pretty much practices the power rule. It's going to be old news for you folks. So find the derivative of these. So y prime would equal 7 times 9 is 63. And it's x to the 1 less power, which would be 6. Here when it's a polynomial, we just take the derivative term by term. 8 times 4, or 2 times 4 is 8. Be x to the first. And then the derivative of minus 6x is just minus 6. And this is y prime. This is one of the trickier ones. Remember, you have to rewrite this as 3x to the minus 2. Actually, now you can also use the quotient rule, and this would work. But using the power rule, 3x to the minus 2, we would get minus 2 times 3 is negative 6, x to the 1 less power. And then we usually put that in the denominator. So y prime equals negative 6 over x to the positive 3. All right, this is the other tricky one. We're going to write this as x to the 1/2. Now that's just rewriting the original function. I didn't take the derivative. So now when I take the derivative, y prime is 1/2, x to the minus 1/2. And after you see this enough, you kind of recognize it. That's the same as 1 over 2 to x to the positive 1/2. And actually, x to the 1/2 is the square root of x. So this is 1 over 2 square root of x. Actually, when you see x to the minus 1/2, probably from now on you should start just thinking it's 1 over square root of x. All right, there we go. All right, this one is not so bad. It'd be 8 times the derivative of cosine x, which is minus sine x. That's y prime. So we get y prime equals minus 8 sine of x. Love those trig functions. All right. This one, y equals 6. That's a constant function. The graph is a horizontal line like that, and its slope is 0. So we should get y prime equals 0. The derivative of every constant function is 0. All right, we're getting there. We're on the back side of the review sheet now. It says find an equation for the tangent line to the graph of y equals x sine of x at the point. So we need the derivative because that gives me the slope of the tangent line. So we need y prime. Now, we see that this is a product, so we got to use the product rule. So y prime is the first times the derivative of the second function plus the second function times the derivative of the first, which is 1. We took a derivative of this in class. Now, so y prime at pi over 2 would be pi over 2 cosine pi over 2 plus sine pi over 2. Cosine pi over 2 is 0, so that's gone. And sine of pi over 2 is 1. So we just get y prime at pi over 2 is 1. And that's our slope. m for our line. So now we can write the equation. We want it at that point. So y minus pi over 2. Oops, not comma. Let me erase that. I want it equals. So y minus pi over 2 equals the slope 1 times x minus pi over 2. And we'll leave it like that for now. Okay. If you did simplify it, you can add pi over 2 to both sides. It actually gets really nice. It's just y equals x is the equation of the tangent line. But you could have left it like this. Alright, the position of a particle moving along a number line is described by the equation s of t equals 4t cubed minus t squared plus 5. S is in feet, t is in seconds. What is the particle's position at t equals 2? Well, we just have to substitute. That's what this function is. So s of 2 equals 4 times 2 cubed minus 2 squared plus 5. That's 8 times 4 is 32, minus 4 is 28, plus 5. I get 33 feet. Okay? Now, find the particle's instantaneous velocity at 2. Well, that would be the derivative. So, instantaneous velocity, v of t, equals the derivative of position, which would be 12t squared minus 2t. And at t equals 2, that'd be 12 times 2 squared minus 2 times 2, which is 48 minus 4, which is 44, and that would be feet per second. Okay, now, is the particle traveling to the left or to the right? It's traveling to the right because the velocity is positive. So, v is greater than 0, therefore to the right. Okay, find the average velocity in this time interval from between 1.9 and 2. So we got to do s at 2, which we already found, minus s at 1.9 divided by 2 minus 1.9. Okay. S of 2, well, we had that above. That's 33. Minus S of 1.9, I get 28.826. Divided by 2 minus 1.9 is 0.1. So let me see what that is. I get 33 minus 28.826 equals, and then divided by 0.1. I get 41.74. And that would be feet per second. Okay. All right. We're in the home stretch now. So we have one product rule question and two quotient rule questions. So remember the rule for the product rule is fg prime equals g times f prime plus f times g prime. Okay, and again, like I mentioned, sometimes they switch these when they write the rule. It doesn't matter. So when we take the derivative of this, y prime would be g, which is cosine x, times f prime, which is 2x, plus we have f, which is x squared plus 1, times g prime, which would be minus sine x. So if I just kind of rewrite it, I get 2x cosine x minus x squared plus 1 sine of x. That's the derivative. Okay, this is a quotient, so we're going to use the quotient rule. So f over g prime equals g f prime minus f g prime all over g squared. This time order is important because there's a subtraction there. Alright, so let's plug in. Y prime equals g, that's x squared. F prime, that would be cosine x, minus f, that's sine of x, times g prime, that's 2x, all over g squared. X squared squared. This looks very familiar. I think we've done this one a couple times. So this is x squared cosine x minus 2x sine of x all over x to the fourth. We can divide everything by x. We have done this. So this is x cosine x minus 2 sine of x all over x to the third. Alright, that's the derivative of that one. Alright, last one. So use the quotient rule again. This is f, and this down here is g. Alright, so y prime equals g times f prime times 0, f prime is 0, minus f, which is 5 times g prime, 4x, all divided by g squared. Alright, this times 0 is just 0. Minus 5 times 4x is minus 20. Actually, minus 20x. And in the denominator, we have 2x squared minus 7 squared. Wow. Alright, that was a calc workout, alright. I hope you got all these answers. If I made a boo-boo someplace, let me know tomorrow. We'll go over it. Good luck.